Below is the graph of the derivative of a function f, whose domain is the set of all real numbers and it is continuous everywhere. Use the provided information to create a sketch of the original function if the only zeros of f are at x equals negative 7.5, x equals negative 1.5, and x equals 3. Well, let's begin making our rough sketch by plotting our zeros on our graph. So we have negative 7.5, which is right about here. We have x equals negative 1.5, which is right about here. And x equals 3 is halfway between 2 and 4. All right. Next, what we're going to do is we are going to create a sign chart for our derivative. Some may need it, some may not. I like to use it because I feel like reading the sign chart is a little bit easier to do when graphing the actual function. All right, so our critical values for f prime are occurring at x equals 5, x equals negative 5 that is, and x equals positive 1. And that is where the function is crossing the x-axis, or where the derivative is crossing the x-axis. And this tells us where we transition from increasing to decreasing and vice versa. So if we look at f prime of x to the left of negative 5, our derivative is positive. That means the regular function will increase on this interval. And then from negative 5 to positive 1, our derivative is below the x-axis, or is negative. That means our actual function will be decreasing. And then to the right of positive 1, or from 1 to infinity, our derivative is positive, which means our actual function will be increasing. Now we can also use this derivative to interpret and explain concavity that's happening too. So I'm going to make a sign chart for f double prime of x as well. And the critical value for our second derivative is where the first derivative has a horizontal tangent. And that's occurring right here at x equals 2. X equals negative 2. And what we can see is the slopes of our tangent lines, or the derivative of f prime of x, will produce negative values to the left of negative 2, and it will produce positive values to the right of negative 2. So that tells us that we will have concave down graph for x values less than negative 2, and we will have concave up for x values greater than negative 2. So our graph will look like this and like this. So now let's actually use these two sign charts and our zeros to graph our function. So we know that from negative infinity to negative 5, we continue to increase. Because negative 5 is in between here, we have to also cross the x-axis. So we are going to be increasing and we are concave down up until we get to negative 5, and then we're decreasing and we're concave down again. And we're going to cross through the x-axis at negative 1.5, and when it's at x equals negative 2, that's where the concavity changes, and we decrease. So we're decreasing and now we're concave up until we get to x equals 1. That's where the minimum is going to occur at. And we are still concave up, but now we are increasing. So this time our function f of x will look something like this. Let's actually see how close we are. Yeah, that's actually pretty close to what's shown in this one.